Hi guys, so this video is about calculating reacting masses using experimental data as well as calculating percentage yield. These are the keywords that we will be using today, which is mass actual, mole ratio, mole theoretical, and mass theoretical, as well as percentage yield. We will be following the steps over here, which will make your life much easier as you work out through these questions. So an example of a question you will be answering could be, for example, like that. You are given an equation and a process, which is what you're meant to be converting into an equation anyway. Usually they would give it to you, or sometimes you have to make it yourself. And so, for example, here, iron. So when you read a question, you need to be underlining the information that is given. So iron Fe is made by the reduction, which means removal of oxygen. So reduction of iron oxide with carbon monoxide. So let's read that again. It means that iron is produced on its own by the reduction of iron oxide. So I'm removing oxygen when I react it with carbon monoxide, which is over here. And another product would be carbon dioxide as a result. So the question says, calculate the mass of iron. So M of iron is unknown, and I will add that on the equation, that can be formed from 100 grams of iron oxide. So here you have 100 grams, and that was given to you. They want you to know how much mass is produced. But the problem is, in a reaction, we cannot deal with masses. We need to convert everything back to the mole language. Hence, we're going to follow these steps. Another question they would ask you is that actually they know how much iron was produced actually. And then they want you to calculate a percentage yield for this process. So the thing is, whatever you calculate in part A is going to be a theoretical mass. And then you're going to compare that to the actual mass and make a percentage and see what yield does it make. This one should be 92%. So let's work our way through the answer. However, before we know how to solve it, the type of questions you will get, for example, you may be given a certain amount of moles, and you are going to find the other moles of another substance using the balanced equation. Now, using the balanced equation, this process is called stoichiometry, by the way. And so we will use the balanced equation in order to find reacting moles, or maybe the product moles, or sometimes you may be asked to find the mass. Or sometimes you are given the mass and you want to find the mass of something else. So ask yourself, can I convert my actual mass into actual moles? Yet. Can I form a mole ratio between these amounts? Yet. Can I calculate theoretical moles from these actual moles that were given from the mole ratio? Or can I convert the theoretical moles to theoretical mass? Do I know yet how to calculate the percentage yield? And do I know its formula? So these are the things that you want to keep as a checklist for yourself. Now, I'm going to follow these steps as we answer the question. So for example, it starts to get more difficult as we go through. So here is the reaction between iron and bromine. Iron reacts with bromine to give iron 3 bromide. 10 grams of iron is reacted with bromine. So they told me that mass of iron here was 10 grams. And so they want us to calculate the amount of moles of iron that has reacted. Okay, so first thing, we want to know what is the reaction about. It's basically iron reacting with bromine. The first step is we want to identify, so the chemicals. At this point, we look at the equation, nothing really required from us but that yet. And then we want to identify the mass that was given. So the mass that was given for us was M of Fe, and that is equal to 10 grams. It's very important that you put the subscript over here so you don't get confused. Then they asked you to find the number of moles. This is an actual value because it's given in the question. They want you to find the number of moles, therefore they want you to find the actual moles. So N of iron, and I will never forget to put that because that will help me with my mole calculation. And it's also actual, that is equal to 10 grams divided by the MR of iron. So because N equals, as we have over here, it's mass over MR. And so 10 grams of iron divided by the MR of iron, which is 56 grams per mole. And you would find that on the calculator, and you are going to answer it as a decimal. Okay, and you have to be careful to take always the minimum decimal point. So you will find that on the calculator. Your answer will be in moles as a decimal. Now, the next thing you want to find out is after you found out the number of moles over here of iron, you want to find the number of moles of bromine that reacted with it. In this case, we're going to follow the steps. So here, identify which chemicals are involved in this question. So here we're talking about iron reacting with bromine. Why is this important? Because we're going to use it in our mole ratio. So you've already found out that the mass of iron is at 10 grams, and you calculated the moles, 10 grams divided by 56 grams per mole. Now, the question wants you to find the moles of bromine that was needed to react with this iron. And that's why we're going to make our mole ratio from the balanced equation. Okay, but first we need to find the value of the moles of iron in decimals. And so basically this value is on the calculator. So it's 10 grams divided by 56 gram per mole. And that is equal to 1.78571. It continues. Okay, so you want to pick for you, like you could for your answer, you could go for two significant figures, which would be 1.8. But on your calculator, keep the big value so that you keep using it, okay? Now, calculate the moles of bromine that it reacted with. Now, I know that this relationship now is between, I've underlined these two, iron and bromine, Br2. Now, I need the mole ratio from the stoichiometry or from the balanced equation, which means it's 2 to 3, okay? And I need to make a mole ratio between them in order to find how much moles of bromine were made. I'm going to use the value of iron that is actually there, which was 1.7857. I'm going to use this value in moles, and I'm going to find N of Br2, which is going to be a theoretical value because I've calculated this value. Any value that you calculate is going to be a theoretical value. And so I'm going to cross multiply, meaning I'm going to multiply this by 3 and then divide by 2. So now N theoretical is equal to 1.785 times 3 divided by 2. Now, N theoretical is I will look oppositely up, and that is going to be of Br2 because it's what we want to calculate from the mole ratio. And that value is going to be, so it's going to be 2.67857, and then you're going to have to round it to 2.7 moles. So these are the moles of bromine that were needed, okay? So that now this takes us to step number 5. So you just calculated the theoretical moles from that mole ratio at this point, okay? So again, you need the moles of one of them in order to get the moles of the other using the mole ratio. Now, we want to find how many moles. We're going to use the same idea to find the number of moles of iron 3 bromide. So now the relationship is between iron, which I already had, its moles, with this one. So now again, I've already done step 1 and 2 in finding the moles and step number 3. And my relationship in step 1 is between Fe and FeBr3. So that's really where students need to stop and take a moment to know which is which. And now we're going to follow the same steps to make a mole ratio. So it's between iron and FeBr3. The mole ratio here is 2 to 2. So 2 to 2, which means it's like 1 to 1. They cancel out. So that means 1 to 1. It reduces. And then I'm going to go back and check what was it was 1.785. So I'm just going to write here 1.785 and N theoretical of FeBr3 is basically going to be the same value because we have, we have a mole ratio of 1 to 1. So that's going to be 1.7, and I'm going to round it to two significant figures, moles. Okay, so that's it. So far, we're doing mole to mole changes. Now, if we are to calculate the mass of iron 3 bromide that was formed. So basically, in the previous question, we found the moles theoretical of iron 3 bromide, and I'm going to use that now. We want to find the mass. So to follow these steps, first, we have underlined those that are reacting, who are involved in this question. So we're talking about iron, and we're talking about iron bromide. So that is the relationship between them. Okay, and step number 2, we found the actual mass of iron. We converted the actual mass into moles by dividing by the MR of iron. And now we need to make we did a mole ratio before. And so they have the same moles because they were equal, like over here. Now we want to find the mass. So after we found the theoretical moles, which came from the mole ratio between iron and iron bromide. So basically that was 2 to 2. Now it becomes 1 to 1. And we put the value that we calculated before as 178. And now I got my M theoretical just to keep it all on one screen. So that is 1.78. But I'm going to write that this is of FeBr3. And that's the trick. Students will always forget which moles are they calculating. They always look at the top. It's going to belong to whatever you're looking beneath it. So now to find the mass, you're going to use the relationship M equals N times MR. Now it's of the theoretical value of iron bromide, because now I'm talking about iron bromide, iron 3 bromide. So N for me is 1.78, okay? And my MR is basically going to be of iron bromide. So iron has an MR of 56. Okay, so that's moles, and that is 56. Plus, bromine has an MR of 80. So it's 80, but I have 3 of them. So it's 80 times 3. And that has units of gram per mole. So then they will cancel out as units, and you will get your answer in grams. So now your answer is 528, and then you can round it also to two significant figures, so that could be 530, and then that would be in grams. And it makes sense because it's like 100. Here it must be more because you will have to combine it with iron in order to produce this amount. Okay, now check again. Can you convert actual mass to actual moles? Basically by using N equals M over MR that was given to you. Can you form a mole ratio between those mentioned from the balanced equation? Can you then calculate the theoretical moles? Can you convert it to theoretical mass? And now let's have a look at percentage yield. Let's solve more examples. First, before going to the percentage yield, I want to give another example here. So how many grams? So this is a reaction. Given the following equation, sodium oxide reacts with water to make 2 moles of sodium hydroxide. How many grams of sodium hydroxide, M question mark, is produced from 100 grams of sodium oxide? Okay, so we're going to follow all of these steps. Number 1, identify which chemicals are involved in this question. Which chemicals? How many grams of sodium hydroxide, so it's this one, are formed from 120 grams of sodium oxide, so it's that one. Okay. Identify the actual mass given. How many 120 grams of sodium oxide? So I'm going to write M actual of Na2O is equal to 120 grams. Then convert the actual mass into actual moles. Now N equals 120 grams, and that's of Na2O, 2O, over the MR of sodium oxide. Now, the MR of sodium is 23, and of oxygen is 16. But I have two sodiums, so that's going to be 2 times 23 plus 16. And I'm going to close my bracket, grams per mole. Okay, that's my moles. And then we're going to use this in our mole ratio. Okay, so that would be 1.94 moles of sodium oxide. The next step, you want to make your mole ratio. Now, mole ratio between which two? Between the ones that I have identified at the beginning, between sodium oxide and sodium hydroxide, because we want to find the grams of sodium hydroxide. So now I'm going to make this relationship between sodium oxide and sodium hydroxide. Now, the mole ratio here, you don't have a number, so it's just going to be a 1. So 1 here and 2. But I have my actual moles from that step over here. So I'm going to say 1.94, and that is going to be N. And anything I calculate is going to be a theoretical value. And that basically, N theoretical of sodium hydroxide is going to be equal to 1.94 times 2 divided by 1. Times 2 divided by 1. So cross multiplication, 1.94 times 2 over 1. So that gives me now my theoretical moles, and that would be just this value multiplied by 2, which is now equal to 3.877, and I'm going to round it to 3.9. However, I'm going to use this value now in my next step. That's why I don't need to round yet. Now, I need to find, so now I calculated my theoretical. Now I want to go to step number 6, which is finding the mass theoretical. Now, to find the mass, it's N times MR, but I have to know MR of which one? It's the one that I'm finding theoretically. So I'm going to look up and I'm going to see which one is it, because if it's confusing for me, I'm always going to use this to guide my eyes, and that's going to be sodium hydroxide. Therefore, I'm going to put my N that I found in the step before, that one over here, and that would be 3.877 moles multiplied by the MR of sodium hydroxide, which would be 23 for sodium, 1 for hydrogen, and 1 for oxygen. And then I'm going to multiply these together. And then this would be, your final answer would be in grams. So you find that to 2 significant figures. Okay, now, to find the percentage yield, it's basically the actual mass for a product given in the question divided by the theoretical mass that you've calculated. So all of the values that we've calculated so far are, in these steps that we've been following, are theoretical. So any value that you will get theoretically on the calculator after the series of steps that we just followed, okay, will be compared to the actual mass, and then you will multiply by 100. So if, for example, we want to solve this question, ammonia is made by reacting hydrogen with nitrogen. I'm going to look at now my equation, hydrogen with nitrogen. Calculate the mass of ammonia, NH3M, question mark, that can be formed from 12 grams of hydrogen. So they gave me M actual of hydrogen, okay, to be 12 grams. So we're going to follow now the steps. M actual for me is 12 grams. N actual of hydrogen is 12 grams divided by 2 times 1, the MR of hydrogen, because it's H2. And then N actual is equal to 6 moles. So now I found my N actual. Then I want to find, because it's between hydrogen and ammonia, the mole ratio, the next step for mole ratio is going to be between hydrogen and ammonia. So basically, it's going to be a 3:2 from the balanced equation. Now, you're going to put the value that you found for actual moles over here, and then you're going to cross multiply 6 times 2 over 3. And that will give you a theoretical moles of ammonia, okay? That is 4 moles if you follow these steps. Now, you found your theoretical moles. You want to get your theoretical mass of ammonia. So theoretical is mass is N times MR. N is 4 moles multiplied by the MR, which is of NH3, so 14 for nitrogen and 1 for hydrogen, but you have to multiply by 3 because you have NH3. So then you get your answer as 68 grams. If you go back, I would say copy these steps and then check that you are working against them in this past paper question, okay? So pause and test yourself. So yeah, you could do this on your own and then check against the answers over here. Now, to get the percentage yield is the equation of actual mass over theoretical. You calculated the theoretical value, which will go as a denominator, and the actual value is given over here in the question. So taking the time to read the question is very important. You're not wasting your time. Times 100, okay? And so you would get 29.4%. Potential reasons why percentage yield is less than 100, because you could have impurities. You can have a reaction that doesn't go to completion because that's a reversible reaction. The reaction could have different conditions, basically for temperature, for pressure, for catalyst, so that might ruin the reaction. Now, check again against these steps, okay, with another question again, and try to solve it on your own, that you can convert actual mass to actual moles, okay, over here, that you can calculate the theoretical moles from the actual moles using the mole ratio. You can find the theoretical moles from the theoretical mass. You can find the theoretical mass from the moles by using N times MR. So this is basically what you are supposed to be learning. Sometimes in some questions, they may make life easier on you. So for example, you might not be given an actual mass. Instead, they may give you just actual moles. That's easy. Good. Then take that and make your mole ratio relationship. Or they might not ask you to find the theoretical mass. They may ask you just to find the they may ask you just to find the moles just by making your mole ratio. Okay, so I hope this was helpful, and this is all for calculating masses and moles using balanced equations and stoichiometry.